Hey, welcome to this session, our Geek Friday session, which will start off with some Pims news, and then we'll have our SQL Geek doing some SQL myth-busting for us. And yes. we won't press the end event button today.
Oh. Good.
Okay, Johnny.
Thank you. Yes. And first of all, yeah, a little chat with Hans Vigleik, because some time ago we introduced the support in Upframe for hierarchy of domains. So Upframe does support that. It's a really great thing, basically inherited from the org structure concept that was implemented in Pims 365 and in Pims R4 that means a hierarchy of domains. So one of the first modules that will have this support is the Action Tracker, and Hans Vigleik is the main developer of the action tracking and updates. We are doing that there to support this feature. So Hans, can you show us a little bit how this looks like?
Yes, thank you, Johnny. First of all, I'm not the head developer of action tracking, but I'm helping out with the upgrade. So basically, what you see now is an markup article of how the action tracking register will more or less end up looking after the upgrade. We will start upgrading the actual action tracking articles next week, and other workflow modules will follow thereafter. One of the reasons to upgrade is to switch to the new AF Bootstrap template. And with that, you get support for what Johnny mentioned, the domain structure or a hierarchy of domains. So I will just show you that briefly, how that's working in the register. So here we have changed to the new AF Bootstrap template, and with that, you get the domain selector. Currently, you see I'm in the Tor domain, and I see all the actions in the domain that I have access to. And if you see here, we have a demo project domain, which is in case a parent domain of Baldav and Tor, and also one source. So if I select a parent domain, I will be able to see all the actions in all the domains in the subtree of that parent domain. If I have access to the domain, and also there are a lot of other custom security around action tracking, so I have to be granted all the access. To actually get this feature running, it's pretty simple. First of all, I have to switch to the AF Bootstrap template. And then I have to add a little code snippet just to listen for changes in the domain selector. And what I get from that is the selected ID path. And instead of selecting on domain, I select the data according to this ID path like, and so on. So that's basically what's needed to do just to get the thing running.
Yes. Okay.
That's more or less what I have, Johnny.
Yeah, that's exactly what we want to do to show us as well. And this is something that will be introduced to the other workflows and to the other products also eventually. And I think that will be very nice, very powerful to have such a hierarchy of domains. But then over to the geek himself, Vidar.
Are you with us, Vidar?
I'm with you. Just trying to share my screen here now.
Yeah.
I'll do some myth busting. I've been asked to have some sessions every now and then about SQL Server. So let's start with one of the weirdest one. Hard disks are almost as fast as memory. Not sure who said this, but I found that a very weird thing to say, but maybe not everyone thinks so. By definition, then getting data from disk wouldn't be a problem. So let's say that one CPU cycle took 1 second. You with me on the analogy? Yeah, Christian?
Sorry, I was muted. Yes.
Yes. So if we then have one call to RAM, how long do you think that will take if one CPU cycle takes 1 second?
One call to the CPU, and the CPU cycle took 1 second. So that one call takes 1 second.
Yeah, so if we just say that when you do one CPU cycle, that's ultra fast. But if we scale it up so that that took 1 second, how long would it take then to do one call to memory RAM? The correct answer is about 4 minutes. So that's just one call to memory. What about then normal SSD drives? We're not talking about the ultra fast SSDs that cost almost 1 million NOK, but just normal SSDs. How long do you think that takes if we compare it like this?
So is that then double 8 minutes?
8 minutes?
Yeah.
Jonny?
32.
32 minutes. Correct answer, 1.5 to 4 days, depending on the SSD drive. And then if you're comparing this to the traditional rotational hard drives that we used to have that are mainly replaced all over the place, how long do you think that takes?
1 month.
Yeah.
1 to 9 months.
You
And
get
then
it.
in some cases, we're unlucky enough to share a SQL Server with other customers, etc., on rotational hard drives. And in those cases, we can expect 4 to 6 years. This is based on, you can click on that link. I'll send this PowerPoint later, but this is the scaling. And the point of this is to show that RAM is very fast, especially compared to SSDs. And it's very important to remember that SQL Server is very happy to use memory, and the more you can put into memory, the better. All right.
Yes.
So myth number 1 is busted. Myth number 2. I see a lot of people using the at table, so the declare table, and some people seem to think that that performs better than the hashtag table, temporary table. The problems with a declarative table is that it is a variable. It's not in any way a table when SQL Server is thinking of it. It's just like nvarchar 128 or whatever. It's not a table structure in SQL Server, so it doesn't do anything like a table. Therefore, it will not perform better than a hash table. Yes, in some cases, you might have the same performance, but you will never have the declarative table performing better than the temporary table. The reason for this is mainly that SQL Server pre-19, so SQL Server 16, 17, etc., will always estimate with 1 row in the declarative table, whilst with hashtag tables or temporary tables, it will actually do statistics like it does with other normal tables. Because a temporary table is an actual table. It just exists in tempdb instead of your normal user database. It also doesn't support parallelism, so it cannot use, even though your SQL Server has 8 or 12 cores or whatever, the query that is using your at table cannot use multiple threads. That means that it will run slower. No indexes. That means non-clustered. You can do kind of like a clustered index on the declarative table. Also, the transactional support doesn't exist for the declarative tables. I've seen countless examples where just changing the @ to a hash fixes performance issues. And here are some examples of this that you see the script on the left side is a declarative table, and the script on the right side is exactly the same. It's only a table instead of declarative. In this case, I think you should mute. In this case, you can see that like SQL Server 19 said that they were not going to fix this problem, but make it better. So if we have a look at the actual execution plan of SQL Server on SQL Server 17, you'll see here that when I select a table scan, you see 101 of 1. That means that it returned 101 rows, because between 100 and 200 there are 101 rows, but it estimated 1. So the of 1 is the estimate time. Whilst if I do the same one on SQL Server 17, you see that the estimate is correct. It's the same as the actual 101. Now, on the right side, you see the SQL Server 19 with the hash table, well, not hash table, but the temporary table, the hash table like that. Still has the same estimate with 101 of 101. But in SQL 19, they said that they made this much better. So now SQL Server doesn't think that there's 1 row. It thinks that there's 9,000 rows between 100 and 200. So that's obviously a very big improvement. For SQL Server, it's better to overestimate than underestimate, but still 9,000 is a bit different than 101. Also in this case here, you'll see that the script on the left returns the result on the right side. With a normal table, you would expect no rows in this, but because it's not transactional, variables aren't transactional. This is not handled like a table, and therefore it doesn't get affected by rollback transaction. One thing that people might not be aware of when it comes to these hash tables is that it's much easier from SQL Server 2016 and onwards to drop table if exists. Before 16, you had to do this if object ID, temp DB, yada yada, and drop table. Quite annoying. So myth number 2 is busted. The declarative table will not perform better than the temporary table. That's what I had ready.
Oh, good. Thanks, Vidar. And I guess at the kind of last, we have a couple of minutes here, and if people want to ask any question, please do so. While we have Vidar here.
Okay, yeah, we have a question for you, Vidar. Do you have any barbecue tips?
Lots.
Yeah.
That's the new.
Just as much as a barbecue geek as a SQL geek, based on the snaps I get from you from time to time. Any other questions more related to SQL?
Or barbecue?
Right.
While they write, I will invite all Omega PS employees to this channel that I've been doing SQL training. Now after summer, we'll start doing some sessions every now and then. I don't have any plan because of my day-to-day job in Westcon, but I'll try to do some more or less ads about it to all employees.
Yeah.
Okay. Yeah.
Yeah, good. And then if anybody has any questions or they think they have a new myth that they want to get busted, then shoot it over to Vidar and let him have a crack on it.
Yes.
Good. But
Yes.
then I think we'll end it for today.
Yes.
Perfect.
Thank you.
Thank you. See you
Thank
then.
you.
Bye.
Bye bye.
Bye.